Good morning, children. Welcome to our chemistry online class. Last class, we have discussed about Thomson model of atom and we have seen the major drawbacks of the model. So, if a drawbacks came, what will happen? The next model will come. So, the next model is done by Ernest Rutherford. He is a student of Thomson's laboratory or Thomson's school, and he was a physicist and he got Nobel Prize for this his gold foil experiment and his model of atom. And he got Nobel Prize for chemistry. So we'll see his experiment and his identification, observation, and all. Rutherford attained atom model by a very famous experiment. This experiment is known as gold foil experiment. We'll see what is gold foil experiment. We'll see Rutherford's gold foil experiment. In this experiment setup, there are alpha particles and alpha particles are there. This is gold foil. That's foil made up of gold. And a screen is there. These all are his experiment setup. We'll see this is the enlarged figure of this gold foil. We know this gold foil is made up of small tiny atoms. It is the enlarged picture of atoms. In that we'll see how this alpha particles will go through the gold foil. So if we add alpha particles, we can see, so the alpha particles are going like this. Some of the alpha particles are moving without any deviation. Most of the alpha particles are moving without any deviation. And if you observe this keenly, you can see some of the alpha particles are leaving in very small angles. Very small angles they are deviating. And few alpha particles are deflecting in very large angles. Observe that figure cleanly. And very few alpha particles, that is 1 in 10,000, are bounce back. These are the experiment observation seen by Rutherford. If you see this one, this pink color are alpha particles that you can see. Most of them are moving without any deviation. Some of this alpha particle are moving in small angles. Some of them are bounce back. A very few bounce back. So we'll see it's an L large. This is considered as center of the atom. We'll see what is happening. We'll trace this one so you will get some idea. So if you see here, this is all is an atom. This part is considered as center of the atom. Later Rutherford called it as nucleus. We'll see. You can see most of the alpha particles are leaving without any deviation, and some of the alpha particles are deviating in very small angles, and very few is moving in very large angles. Why it is happening? He thought. Then he identified, he come to some ideas and explanation. You see this one with traces with this one. In this figure you can see most of the alpha particles are moving without any deviation. Here you can see, and very few, some of the alpha particles are deviating in very small angles, and very few is deviating in large angles, and some of the alpha particles are bounce back. Not some, very few. Here you can see this one. This is the experiment setup of Rutherford. So what all things he identified from this experiment, that we will see. So we'll see Rutherford's experiment setup and its observations and limitations and atom model and all. So in this experiment setup, Rutherford conducted an experiment by bombarding a thin sheet of gold foil with alpha particles and then studied the trajectory of the alpha particles while the interaction with the gold foil. So in this experiment setup, here you can see a gold foil, that is a thin sheet of gold metal. Why he selected gold foil? Because we can make gold as much as thin. So for our experiment we need very thin layer. For his experiment he need a very thin layer. So gold metal can easily make as thin sheets. So he selected gold foil. Then there is a detecting screen, a zinc sulfide screen. Detecting screen is used to study the movement of alpha particles. If any particle touched on a deflected screen, it will show that fluorescent like luminous flame. So we can identify the track of the the alpha particles. And he used an alpha particle. He used alpha particle for the study from the this is alpha particle emitter. So here a small slit is there. So from a small slit, alpha particles is in the form of beam of light. So it will pass. So why he selected alpha particles? Alpha particles having high penetrating power. So he choose alpha particles, and alpha particles also having positive charge. So keep it in mind, alpha particles also having, keep it in mind, positive charge. So this is his experiment setup. Gold foil, alpha particles and detecting screen. So we'll see his identification. So we'll see his identification by the video. So these are his observations. So their radioactive source you can see. From there a pinhole is there. From there our beam of alpha particles are passing through this gold foil. So we know in gold any substance we take, it is all made up of atoms. So this is the arrangement of atoms in a gold foil. So what are his observations? Here you can see a small fraction of are deflected, that is it is deflecting. Most of the alpha particles pass through any deviations, any disturbance, they are moving freely, and a very small fraction bounce back. If you throw a ball to a wall, it will hit back. Similar to that, a very small fraction of alpha particles bounce back. These are his observations. 3 types of alpha particles he identified. So what we can conclude from these observations? So there are 3 types of alpha particles. The first one is most of the alpha particles were passed without any deviation. From this, he identified that most of the space in an atom is empty. If you observe this picture, you can see the alpha particles moved without any deviation is passed through empty space. Empty space. Consider this as an atom, or this as an atom. You can see here most of the alpha particles moved without any deviation, passed through the empty space of an atom. So he concludes that most of the space in an atom is empty. This is the first postulate of Rutherford model. Then we have seen a second type of alpha particles, that are very small alpha particles were moved in very small deviation. Why this small deviation happens? Here you can see a small deviation. this is having a small deviation. So we know alpha particles also having positive charge, and if any positive charge substance are moving like this, if it is deviating from its path, why it will happen? How it will happen? What can what type of things can change the path of positive substance? If it is negative charge, those will attract each other. But if there is any other positive charge, they will repel each other. So the repulsion causes the small deviation. So he identified that there is a positive charge inside the atom, and a very small number of alpha particles were moved or deviated in small angles. So he considered that there is a small volume of positive charge inside the atom. This was his second observation or second postulate of Rutherford model of atom. Then we move to the third one. That is, here we have seen very few alpha particles were bounced back, 180-degree deflection. Why? How it will happen? If it is, we know alpha particles also having positive charge. If it hits any positive part, then only it will deviate or it will bounce back. So the volume occupied by the positive charge particles in an atom is very small compared to the total volume of an atom. And in the center, he also identified that the positive charge is in the center of the atom. He called it as nucleus. So we'll see Rutherford's atomic model. This is Rutherford's atomic model. So here you can see in the center of the atom there is the nucleus which is having positive charge. Electrons are revolving around the nucleus in orbits. This lines he called it as orbits. And this model of Rutherford is also known as solar system model. Here you can see, we know in the solar system, sun is the center of the universe, the solar system. Sun is the center. All other planets are revolving around the sun. Similar to this, here sun, instead of sun, here nucleus. Planets are electrons. Considered planets are electrons. So electrons are revolving around the nucleus, similar to the planets are revolving around the sun. So this is the atomic model of Rutherford. His conclusions are most of the space in the atom is vacant, and in the center of atom there is nucleus which is having positive charge. Electrons are revolving around the nucleus in the orbits. So we'll see, but this model also failed. We'll see the limitations of Rutherford model. Here he said that electrons are revolving around the nucleus. We know if we run very fastly, after some time we will fall. So he said electrons are revolving continuously around the atom. So if we take any substance which is revolving continuously, what will happen? It will lose its energy, isn't it? If we walk or if we run, after some time we will lose our energy and we will fall. Similar to this, if electrons are revolving continuously around the nucleus, after some time it should be fall. If it is fall, the atom will be unstable. Is it true? No. If we check any substance, any matter, all matter is made up of atom. We know all matters are highly stable. An atom is stable. Then this is the major drawback of Rutherford model. So orbiting electron should emit light or energy, losing energy in the process. This energy loss causes the electrons collapse into the nucleus. So if it is revolving around the nucleus, we know it's having positive charge, it's having negative charge. It will attract here and it will collapse on it. But it's not happening actually. So it was the major drawback of Rutherford model. And one more drawback is he could not mention anything about the arrangement of electron in the orbit. So these are the major limitations of the Rutherford model. So if a limitation comes, what will happen? Next model comes. So we'll see the next model in next class. Thank you.